The zeros of a function are the x-intercepts. So we have zeros, x-intercept, solutions, and what's the other one?
Zero.
Got that one. Roots. Those all mean the same thing. So given a polynomial function, so if I give you p of x, if p of a equals 0, remember what is in parentheses is your x value. So if you have your x and then the y is 0, it is a root or x-intercept. So if your f of x is equal to 0, then that x value is an x-intercept. It's when the y value is 0. Now, assuming that that x value is a real number, because we're going to throw in some i's really quickly here. If it's a real number, if it's like 2, if f of 2 equals 0, then that tells me that that function has a factor of x minus 2. Because remember, all of the examples that you had on that Desmos, it was factored. X minus 2 crossed at the x value of 2. So if I'm giving you the x-intercepts, we're going to write out the linear factors. So if I have an x-intercept at 2, what is that factor that's in parentheses? If you have an x-intercept at 2,
0.2.
no, I'm talking like this, x minus 2. And what's the other factor? X minus 5. Yep. So these are factors. If you have an x-intercept at -4, what factor goes with that? X plus 4. And then we would have what? X minus 1 and x minus 7. Yep. So a factor of x minus 7 means that you have an x-intercept at 7. Okay. If you have an x-intercept at 0, your factor is just x. And then what would go with the -6? X plus 6. And then I have, what else? X minus 3. Good. Now the multiplicity, so we talked about that in Algebra 2. That's when the ones that you had the squares. The multiplicity of a factor is the number of times that 0 is repeated. Or that x-intercept or that factor is repeated. So if you have an x minus 2 squared, the multiplicity is 2. So multiplicity is when you have everything factored. So all of the examples, you have like x minus 2, x minus 5, that's in factored form. You can look at, so if you're given the polynomial in factored form, you look at the exponents. Exponent, it would just have one, of the factor. So you can only tell the multiplicity if the polynomial is factored. If it looks like this. If it looks like this, that is not in factored form. You cannot tell the multiplicity right here. It has to be factored. So you look at the exponent of each factor, would tell you the multiplicity. So here I have a function. I've given you the equation. What are the x-intercepts? -4, -1, and 3. So I could tell that by looking at the picture, or I could tell that by looking at my factors. -4, -1, +3. So at the x-intercept of -4, what does the graph do at that x-intercept? What does the line do? It crosses through the x-axis. Yep. Now at x equals -1, it still crosses through because it started out above, but it kind of goes sideways a little bit. But we would still say that it crosses through. What about the x-intercept at 3? It bounces. In Algebra 2, we use the terminology bounce. So once the line went up to the x-axis and hit the 3, it bounced off, or it changed direction. And all of that goes back to the multiplicity. So notice at the x-intercept of -4, the multiplicity there is 1. If you don't see an exponent, you would assume that the exponent is 1. So it had a multiplicity of 1. And that one, when it's a multiplicity of 1, it like crosses right through. It's like real easy to see that. The x-intercept at -1, what's the multiplicity there? 3. It still crosses, but it did the weird like sideways thing. That's specifically because the multiplicity is 3. Anytime you have a multiplicity of 3, it'll do that to some degree. Now it might be real quick, it might be longer, it all just depends on the other numbers in the function. And then what about the one where it bounced? Multiplicity is 2. Anytime you have a 2, or actually an even number, let's see. Okay, yeah. So if you have an even number, it's going to bounce. If you have an odd number multiplicity, it's going to cross. We did that a little bit in Algebra 2, advanced. So in general, if the factor has an odd multiplicity, then the graph crosses at that 0. So all of these are an example of where it crosses. Those cross through really nice. So those x-intercepts probably have a multiplicity of 1. Okay, but also something like that still has an odd multiplicity, but it's probably 3, maybe even 5. So those are all considered odd multiplicities. If the factor has an even multiplicity, the graph bounces at that 0. So this would be an example. This one has the two x-intercepts. And it bounced. Okay. Alright, so here I'm going to describe a function and you're going to sketch it out. We'll do some of them together. The function has a 0 at x equals 1. With a multiplicity of 3. So first of all, what does the linear factor look like if the x-intercept is at 1? What's in the factor? If you have an x-intercept at positive 1, what's the factor? X minus 1, and it has a multiplicity of 3. So it has a cubed. And this function has a 0 or an x-intercept at x equals negative 2. What does that factor look like? X plus 2 with a multiplicity of 2. So there's negative 2. So I know that my graph needs to bounce at negative 2 and it needs to cross at positive 1. Now, since my multiplicity here is 3, it's not going to be a real nice cross through. It's going to kind of go sideways probably. So sometimes with these, you start to sketch it out and then you realize maybe, no, that doesn't look right. You might have to erase and try again. Let's see. I don't know. That might not be a very good example. X minus 1 cubed x plus 2 squared I mean, that's really what it looks like, but so something like that is fine. And the numbers, like a number that is in the front drastically changes. Like some of your examples that you might have put a 5 in the very front, your like lines went where they were real close together like this. Some of them were more spaced out. That all has to do with the number that you put in the very front. Okay. Number 5, the function has a 0 at x equals negative 3 with a multiplicity of 2 and a 0 at x equals negative 1 with a multiplicity of 2. So draw what you think that graph could look like. That's a possible example. Yours could also be upside down because I'm not telling you what number would go in the very front, so it could flip it upside down. Right now, this is actually this would be if there was a negative in the front, would make it go upside down. But it should not actually cross through it all. You probably wouldn't. With like just a generic word problem. Like here, the multiplicity, when it tells me the multiplicity, that's how I know for these examples. But in a real world situation.
How does the multiplicity
If the multiplicity is an odd number, it completely crosses through it. If it's an even number, it bounces. Alright, so here we have an x, or a 0 at x equals 0. Has a multiplicity of 1, which means it's going to just be a nice cross through. A 0 at x equals 4 with a multiplicity of 2, so it's going to bounce. And at -2 with a multiplicity of 3. Alright, so now it's going to cross through there. It's going to come back up here and bounce. That fits, I think. Crossed through at 0. Bounced at 4. Crossed through. So what you're likely to see as a question on the test, and I've seen some example questions like this. You might be given just a very generic picture like this, and it'll be some multiple choice questions. It'll say which one best fits the graph. It would be non-calculator based. So your right answer would be something like this. X plus 3, x minus 2 squared. So this right here would tell me that I have an x-intercept at -3 and it crossed through. That looks like it could be -3. That seems reasonable. And an x-intercept at +2, but it bounced. So you would see things like this. You would probably have an example that's x minus 3, x plus 2 squared. It wouldn't give you numbers that are real close. Like I wouldn't give you another example that's x plus 4, x minus 3 squared. Because you can't tell, is that 2, is that 3, is that 4? There's no scale on the graph. You would specifically just know at the positive, on the positive side, it bounced. Okay, on the negative side, it crossed. Alright, I know, we're like, these units, there's a lot cram-packed. Like, we spent just one lesson talking about multiplicity in Algebra 2. We can't do that now. So, complex roots, these are when you throw in I. So a complex root just has an imaginary number in it. What causes you to get an I in anything? When did we start seeing I's? Something negative. Just a negative number in general is not imaginary. What caused you to get imaginary numbers? Square root of negative numbers. When you start having to take the square root of a negative, that throws in some imaginary numbers. So some polynomials have roots that contain an imaginary number. This means you will not see them on the graph. It really, the x-intercept really isn't there. If you tried to solve with the quadratic formula, you would get an I in there. So look right here. We have this quadratic. If I said find the x-intercepts, what are you going to say? There aren't any. Well, actually, there are. They're just imaginary, which is really confusing anyway. But if I tried to take this equation, x squared plus 1, x squared plus 1, and set it equal to 0, and I tried to solve that, so setting our equations equal to 0 is how we solve quadratics. That means finding the x-intercepts. We did that in Algebra 2. We factored. We did the quadratic formula, okay? So you would subtract 1, And then you go to take the square root. But you can't do that. It's imaginary. So if you see i's, imaginary numbers, okay. The big key thing that you need to know right now is that all imaginary roots come in pairs. So you can't have one imaginary x-intercept. You can have 2, you can have 4, you can have 6, but you can't have one. They come in pairs. Imaginary roots. Remember in the quadratic formula there's the plus and the minus, the plus or minus? That's what forces them to come in pairs. So if one of your x-intercepts is like 5 plus 3i, that's a common way you'll see them written out, 5 plus 3i. If that's one of the x-intercepts, then so is 5 minus 3i. So if you have a plus, you also have a minus. So in general, if a plus bi is one of them, so is a minus bi. Imaginary roots come in pairs. There's always an even number of them. We call that special word, just meaning they come in pairs, we call that, oh, I spelled it wrong, conjugates. Conjugates. So a plus bi and a minus bi are conjugates. Oh man, I think so I think question 7 is just 4i. So if I say find the conjugate of 4i, your answer is negative 4i. The conjugates change the sign. So 4i and negative 4i are conjugates. What do you think the conjugate of negative I would be? Positive I. And then we have negative 4 plus 2i. The only sign you change is the one right in front of the I. So the conjugate of that one would be negative 4 minus 2i. What if I give you 7 minus 3i? What's the conjugate? 7 plus 3i. If you have one, you automatically have the other. So for example, here's kind of where it might come into play. Alright, here's a graph. I'm telling you that that is one of the x-intercepts. If that's one of them, what does another x-intercept have to be? Specifically, what if I have one that is I square root of 3? It's imaginary. It has to have a pair. What would its pair be? Negative I square root of 3. So if you have I square root of 3, you have negative I square root of 3. We also have an x-intercept at 4. And we have an x-intercept at negative 1. So from looking at the graph, I can tell we have an x-intercept at negative 1, 4, and then the only reason that I know the I square root of 3 is because the problem told me that. I can't get that from looking at the graph. So I have the I square root of 3, and then this question is really asking, do you remember that those come in pairs? You have I square root of 3 and negative I square root of 3. So those are your x-intercepts. The question is asking what is, well, hold on. So if it's asking if the function has degree n, it has some degree. What is the least possible value of n? If I have this polynomial, that one has a degree of 2. That one has a degree of 3. Why did the degree go up? Because of that multiplicity. What would the degree of this one be? 6. That one was 2. That one was 4. Okay. So if I have an x-intercept, so these are separate x-intercepts, okay? But the degree or the multiplicity causes your degree to go up. Okay. So if I looked at the graph of all of these, all 3 of them would cross the x-axis at -2 and -3. But their degree is all different because of the multiplicity. Now, in this example, I have I square root of 3, I have negative I square root of 3. At the x-intercept at -1, notice it bounced. What does your degree have to be for it to bounce? Has to be even. What's the lowest even number? 2. So that factor is at least x plus 1 with a squared. So this question is asking what's the least possible degree? Your answer is 5. Okay, here's why. We have 1, 2, 3, 4, 5. These count as an x-intercept. Each of those are degree 1, at least. Degree 1, degree 1. Could I have a degree 1 that crossed through? Crossing through is 1, 3, 5, 7, 9. So at least a degree of 1. The bounce right here has to be at least a multiplicity of 2 because it bounces. So I have to count that one twice. This is a very complicated question. It's asking what is the least possible degree. You have the 2 imaginary numbers. You have the x-intercept that crossed. The x-intercept that bounces has to count twice because anytime it bounces, it has to count at least 2, 4, 6, 8, 10 times. 2 is the least. That's really complicated. So let me throw a couple questions at you. All right. If I have an x-intercept at 2 plus 4i, where else do I have an x-intercept? Oh. 2 minus 4i. Good. All right. What if I say, okay, I have an x-intercept at 3i. My graph crosses at x equals 4. and it bounces at x equals 1. I have a graph. I'm telling you one of its imaginary roots is at 3i. It crosses at x equals 4, and it bounces at x equals 1. I want to know the least possible degree. Five? 4? I'm going to go with 5. If you have 3i, you automatically know you also have what? Negative 3i. So that gives you a degree of 1, 2, crosses at x equals 4, 3. If it bounces, it counts at least twice. Okay, 2 is the least. So that gives me my 5. All right, let me give you another one. I have an x-intercept at 2i, 4i, no, 5 plus 4i. Bounce at 3, bounce at negative 1. What is the least possible degree? Least possible degree would be what? If you have 2i, what do you also have? If you have 5 plus 4i, what do you also have? If it bounces at 3, that counts as at least 2. And bounce at negative 1, that's got to count twice. 1, 2, 3, 4, 5, 6, 7, 8. Your least possible degree is 8. All right. Let's do another one. You have an x-intercept at 2 plus I. Cross at x equals 0. Cross at x equals 3. What is the least possible degree? 4. You have 2 plus I. You also have what? 2 minus I. Crosses, that can be just 1. It could also be 1, 3, 5, 7, 9 as a multiplicity, but we want to know the least. So 1 is the least. So you have 2 plus I, 2 minus I, and then 0 and 3. Those can only count as 1. All right, I'm going to give you just front and back. I will give you some time in class tomorrow. And the back has the answers. Oh, I forgot to stop recording. Oopsie.